We're looking at the final few problems here on the AB Fall Multiple Choice Review, number 55 through 60. Last page here. 55, find the derivative of f of x for natural log of root x squared plus 1 over x 2x cubed minus 1 squared. Now, we don't want to find the derivative at this point because the derivative rule for u prime over u, we have to go through quite a bit of a messy step of having to expand or having to going through a series of chain and quotient and product rule. So to make things easier, we're going to take advantage of these log properties since this is a log expression. If we can expand this out using log properties, then we'll have smaller portions, which will make it easier for us to find the derivative for each of the portions broken up. So this is essentially the natural log of a over b times c. So I can split this up into natural log of a minus natural log of b minus natural log of c. So all the denominator terms are basically going to have a negative in front. And we're splitting this up into three natural log expressions. And we're going to continue expanding by bringing the exponents down. So bring down the 2 and the 1/2 as coefficients. And now the derivative for each of these terms will be a lot easier to manage. So the derivative for natural log of u is u prime over u. So 1/2 stays. U value is x squared plus 1. So u prime, x squared plus 1 becomes 2x. U prime over u minus, and then we do u prime over u for natural log of x, which is 1 over x, minus 2 is the coefficient. Natural log of u is u prime over u. So 2x cubed minus 1 becomes 6x squared over 2x cubed minus 1. And now it's just a matter of trying to clean this up. So the 2's cancel out. And then the 2 times 6 becomes 12x squared over 2x cubed minus 1. And now these three terms, we see we have a match with answer choice D. 56, find y prime if y is equal to x cubed over 3 to the x. Notice we have a numerator and denominator portions. We have to go through quotient rule. But if you look at the denominator, this is a base raised to an exponent. So this is in the form of an exponential function, but it's not base e, this is base a. So the derivative for base a to the u is natural log of a times a to the u times u prime. So we go through quotient rule. F prime g minus f g prime. So x cubed becomes 3x squared. So 3x squared. F prime g minus f and then g prime. So g prime, we're going to apply the rule for a to the u. So a is 3, u is x. So natural log of 3 times a to the u, so 3 to the x, times x's derivative, which is times 1, all over denominator squared. So 3 to the x squared. And I'm going to try to clean this up here. I'm going to try to find common factors between the numerator. I can factor out a 3 to the x. And that leaves me with 3x squared minus x cubed natural log of x. Denominator, I can split this up into 3 to the x times 3 to the x. I can cancel out one of the 3 to the x's. And I can factor out another x squared. So x squared times 3 minus x natural log of 3 over 3 to the x. And that matches answer choice D. 57, find f prime for f of x equals 2 over 2x plus e to the 2x. We have numerator and denominator. I guess we could bring this up and go through chain rule, but this is a pretty complex term, so I'm going to leave it in quotient rule form. Now, 2x is just power rule, but e to the 2x, just as to help recall, the rule for e to the u is e to the u times u prime. So let's go through quotient rule. F prime g, so constant's derivative is 0, f prime g minus f g prime, so the derivative of the denominator, 2x becomes 2, e to the 2x becomes e to the 2x times 2 because of the rule e to the u times u prime. All over denominator squared. 0 times anything, which is going to be 0. Combine, I get... I can factor out another set of 2's. So I factor out another set of 2, I get negative 4 times 1 plus e to the 2x all over 2x plus e to the 2x squared. and that matches answer choice C. 58, if log base 3 of x cubed minus 8x, find dy over dx. So we have a rule for log base a. The rule for log base a is 1 over natural log of a times u prime over u. So essentially same as natural log of u. We just have to go through this bit of a conversion with this 1 over natural log of a. So our a value is 3. Our u is x cubed minus 8x. So we just follow the rule. So 1 over ln of 3. Okay, a is 3. Times u prime over u. So the derivative of my parentheses here is 3x squared minus 8 all over u. And now I can put all this as one fraction. So 3x squared minus 8 over natural log 3 times x cubed minus 8x. And that's answer choice B. Okay, 59. Find dy over dx for y equals arc tangent of x over 2. The rule for arc tangent of u is u prime over 1 plus u squared. So our u value is the x over 2, or 1/2 x. So the derivative for 1/2 x, u prime, is just going to be 1/2 all over 1 plus u squared. So 1 plus 1/2 x quantity squared, 1/2 x quantity squared, which is x squared over 4, and 1/2 over 1 plus x squared over 4. I'm going to multiply everything through by 4. That will allow me to redistribute these values that's causing this complex fraction to the other terms in the fraction, which will allow us to eliminate these denominators. So multiply numerator and denominator by 4. I'm not changing anything. I'm just essentially multiplying the fraction by 1. 4 over 4 is 1. So multiply the 4 to the numerator, I get 4 over 2, which is 2. Multiply the 4 through the denominator, 4 times 1 is 4. And then the 4 in the numerator and denominator multiply to be canceled out to be 4 plus x squared. So 2 over 4 plus x squared, answer choice E. Okay, finally number 60. F of x equals 1 over 27, parentheses x to the 5th plus 2x cubed. G and f are inverse functions of each other. We want to find g prime of negative 11, and we're given order pair. So here we have to establish the relationship between the function and its inverse. Between the function and its inverse, so f and g are inverse functions as provided here. Okay, and we know that a function and its inverse will always have ordered pairs that are flip-flopped or reverses of each other. So if AB is the ordered pair for f, then BA is going to be the ordered pair for G. Okay, so they're going to have flipped versions of ordered pairs. They're going to have these corresponding points, always have corresponding points between the function and its inverse. And then at their corresponding points, there's also a relationship in terms of their slope. So whatever the slope is for one function, the other function's derivative at their corresponding point will be the reciprocal. So not the negative reciprocal, but simply the reciprocal. So if that's the case, I'm going to set up a table that demonstrates or that shows the relationship so I can kind of see what I need to find. So I know that G and F are inverses of each other. Negative 11 is the x value for G, and negative 3 is the y value for G. Now, if the order pair for G function is negative 11, negative 3, then that means the order pair for its inverse must be the flipped version, must be flip-flopped, must be negative 3, negative 11. So I'm going to just establish that relationship here. So G of negative 11 is negative 3. For the inverse, the order pair must be negative 3, negative 11. Okay, so I've established the relationship in terms of their order pairs. Now, at their corresponding points, they're also going to have a relationship in terms of their slope. So we're given information about f of x. So if I can evaluate the derivative of f of x at negative 3, then I can use that slope to figure out the slope at g prime of negative 11, because we know negative 3, negative 11 are corresponding points, or x and y values of corresponding points between inverse functions. So let's find f prime of x. To find f prime of x, I'm just going to find the power rule, because 1 over 27 is the coefficient. It's just going to stay put. X to the fifth becomes 5x to the fourth. 2x cubed becomes 6x squared. We're going to evaluate the derivative at negative 3, so plug negative 3 in for the x's. So 5 times negative 3 to the fourth is 405. 6 times 9 is going to be 54. Add, divide by 27, and we get 17. So if f prime of negative 3 is 17, then we know that g prime of negative 11 must be the reciprocal of 17, right, which is 1 over 17, and that's our answer.